So welcome to another tutorial, just a continuation on the cardiovascular system. So the last session, I described part 3 of the cardiovascular system. I described the pacemaker potential. So the pacemaker potential I'm describing is actually the action potential in the SA node. Just understanding it at cellular level, how it manages to generate an action potential, bringing about the contraction in the atrium and the ventricles. Now today we are specifically looking at the myocardium action potential. So this is the action potential that is actually transmitted to the muscles of the ventricle, okay, which is the myocardium. So unlike the pacemaker potential, the myocardium action potential is quite different because in the myocardium action potential we have the plateau phase, as you can see it there. So some important points to get is that the myocardium action potential actually has the resting membrane potential of about um, -90, as you can see here, approximately. Here there is 100, but it has about -90 millivolts. That's the um, membrane potential for myocardium. So those are potential MCQ that you should note. So in the myocardium action potential, we actually have phase 0, then we have phase 1, then we have phase 2, then we have phase 3, and we have phase 4. Now let's describe what really happens in each and every phase. Okay. So in phase 0, we call this initial depolarization. Why? Due to sodium influx. Okay. So at this point, we call it initial depolarization because sodium start entering inside the cell. Just like the pacemaker potential, even here there is influx of sodium. So the major determinant of depolarization in a pacemaker action is actually the calcium, which opened during L type. But on the phase 0 of the myocardium action potential, there is just influx of sodium going in slowly. Remember the graded potential, we want to reach a certain level. Okay, so that was phase 0. There is just actually rapid upstroke or depolarization due to sodium channel which is entering. Okay, so we can also call this spontaneous. Then, what is phase 1? Phase 1 is actually initial initial depolarization, sorry. So, initial repolarization. What happens in phase 1 is that, remember the ion that is responsible for repolarization is actually calcium. Sorry, potassium. So what does this potassium do? Potassium movement is always outside the cell. So once it is leaving the cell, it is making the membrane potential inside the cell less negative. That's why we have depolarization. So as you can see here, the phase 1 is actually initial depolarization due to what? Potassium efflux. Okay. So there is actually, since depolarization has already happened here in phase 0, so here we want to deactivate the sodium voltage gated channel. So at this point, there is inactivation of sodium voltage gated channel. Then from phase 1, we go to phase 2. This is also known as a plateau phase. So what happens during a plateau phase is that at this point, calcium start coming inside the cell. Okay. Whilst, remember during phase 1, we described it depolarization. So during depolarization, potassium was leaving the cell, but calcium start going inside the cell. Now the problem here is that why does a plateau form is the rate of calcium influx equalizes with the rate of potassium efflux. So what I mean is the amount of potassium leaving the cell is get to be equal to the amount of calcium entering the cell. So simple illustration is like you are transporting students from a classroom. Maybe there are 25 students in a classroom, but at the very moment you want to transport 5 outside the classroom, you also bring 5. So it means that there is no difference. That's why we have this plateau phase here. Okay. And what is the importance of a plateau phase? This is actually very much important. The prolonged phase allows for complete ventricular filling so that the ventricles can fill in with blood before they can contract. So phase 2 in summary, as potassium leaves the cell, calcium starts going inside the cell. But the rate is almost the same. That's why there is a balance. Then this phase trend to prolong. Then from phase 2, we go to phase 3. What is phase 3? Phase 3 is rapid repolarization. Now, remember potassium was leaving the cell, then here calcium was entering. That was phase 2. Then phase 3 is rapid repolarization. What do you think is happening? So during phase 3, what really happens is that since this potassium efflux, potassium leaving the cell is high, okay? Potassium is leaving the cell more rapid, and the calcium channels at this point get to be closed. They become inactive. There is no balance that caused this plateau in phase 2, since calcium is no longer entering inside the cell. So the cell is becoming more negative. So that was phase 3. So now we have phase 4, which is the resting membrane potential. What is causing the resting membrane potential phase 5 is that there is actually high permeability of potassium among the medium, okay, outside the cell. So potassium is highly leaving the cell. Remember in phase 3, calcium becomes inactive and there is no ion which is moving inside the cell. Hence, bringing this membrane potential to negative 90. So this is all about the myocardium action potential. So you should be able to differentiate myocardium action potential from the pacemaker action potential. So the major ion that caused depolarization in pacemaker action potential was actually the calcium channels through the L type, okay? But in here myocardium, the major depolarization was caused by sodium voltage gated channels. Those are simple questions that you can encounter. Okay. So if you reached this far and you found the video interesting, just make sure that you like the video and subscribe.